The final subject we are going to talk about this week is the famous P versus NP problem. Now we defined the class P and we defined the class NP of problems. And we have also established that, well, this is obviously not N, but P. We have established that P is a subset of NP. But what we don't know is whether P is a proper subset or is actually equal to NP. Okay, so let me repeat that. We do not know whether P equals NP or P is actually a proper subset, meaning that there are problems in NP that are not in P. So we have no answer to this question at this point, and this is one of the most famous open problems in all of mathematics currently. It is so important that it's one of the so-called Millennium Prize problems. There were 7, and as far as I know, 1, maybe 2. I'm not sure about the second one. Only 1 has been solved, and to anyone who can solve one of these problems, the Clay Mathematics Institute offers a $1 million prize. Okay, so these are this is one of the most famous problems in mathematics currently. And let's talk about the implications. What if P equals NP, and what if P doesn't equal NP? If P equals NP, we have this picture on the right-hand side. In this case, P equals NP, and it also equals the set of NP complete problems. And all of them together is going to be a subset of NP hard problems. Okay, because they can be reduced to, all NP problems can be reduced to NP hard problems. If that is not the case, if P and NP are not the same sets, in this case, P is a proper subset of NP, and NP complete problems in this case are not in class P, so we will have to forget about any hope of finding polynomial time algorithms for NP complete problems, and there will be a third class here which we call NP intermediate. Now the existence of this we are not sure at this point. Okay, so if it is the right hand side the correct picture, or is it the left hand side, we actually do not know the answer. But if the question is settled someday, then there will be ramifications. We are going to talk about cryptography later on, and I'm going to come back to this and what are the ramifications, whether right hand side is true or left hand side is true, because a lot of things actually ride on the distinction of these two sets. At this time, at least for practical purposes, we are sort of assuming that P and NP are not the same. But it might happen that because we haven't proven that P and NP are different. We haven't proven that. Nor we have able to find a solution in polynomial time to any of these problems in the NP complete class. So if somebody comes up with a solution to, let's say, the satisfiability problem, then of course they will be very rich. But apart from that, we will have to revisit a lot of problems and a lot of algorithms and a lot of methods that we have been using in daily lives constantly. Okay, so this is an extremely important problem, and you have to know the extent of this. You have to know what it means, what is NP, what is P. Well, P is easy, but you have to understand what NP is. It is not non-polynomial. It's non-deterministic polynomial. So that there is a significant distinction between the two. You have to really understand what class NP is and what are the ramifications if P equals NP, or rather P doesn't equal NP. At this point, as I have said, We do not know the answer to this question, but an overwhelming portion of people actually think that it's the case that they are not equal. But as I have said, we actually do not know.